So today's our next chapter we are having, that is chapter number 6, gravitation. Okay, so gravitation was basically found by the Newton. So this is basically a process or a phenomena, you can say that, by which all the bodies attract each other with a force or any kind of attraction. So this is just because of the body masses. Okay, that attraction is called the gravitation. Okay, so for example, I'm having this body A, and this is body B. Okay, and this is the center of this body, and this is the center of the body. We can say that this is the radius of this body, radius between two bodies. Okay, and here between two bodies there is an attraction, or there is any kind of a force which both bodies are attracting. So that we are calling that as a gravitation force between them. That is called the gravitation. And yes, this is also a, you can say that we are having also a law of that, Newton law of gravitation. Newton law of gravitation. We are having a law on this, Newton law of gravitation. What does it mean? It means that there is a statement that every body in the universe attract every other body with a force, that is gravitation force. Okay, so if we talk about the Newton law of gravitation, so with that there is the additional point with that is that whose magnitude is directly proportional to the product of masses. What does it mean? Product of masses, and inversely proportional to the square of the distance between them. This is the statement of the Newton law of gravitation, that this one, you can say that the gravitation force is directly proportional to the two masses, which is m1 and m2, and the square of the radius between them. And this is the equation number 1, we can say, and the square between the radius between them. Through this equations we can calculate the, you can say that, the gravitation constant value, as well as the gravitation constant, universal gravitation constant 2. This is the equation number 2. Okay, by combining both relation I can write that Fg is directly proportional to the m1 m2 upon r square. Okay, by combining these both, so I can write here that gravitation force is equal to the m1 m2 upon r square. Okay, here we are having the g. After removing the sign, we are having a g, which is a constant. We are calling that as a universal gravitation constant. Universal gravitational constant. Okay, and as you guys all know, there was a scientist whose name was Lord Henry Cavendish. With the help of torsion, there is a torsion like this. With the help of the torsion, he told the value of the g, which is, this is the capital G. And as you guys all know, we are having the g value, that is basically, you can say that the 9.8 meter per second square. This gravity can be changed, but if we talk about the gravitation constant, that cannot be changed. This is a constant value. Okay, so we can write here that Fg is equal to the g m1 m2 upon r square. Gravitation force is equal to the g m1 m2 upon r square. Okay, if we talk about the you can say that the the formula he calculated, that was the formula. With this formula he calculated actually this one, gravitation force formula, that G is equal to, gravitation constant is equal to the F multiplied by R square upon M1 M2. Okay, so here you can say that this is a square between the two masses. Okay, and this is the m1, the two bodies square between the two masses, and there is a force. So we can write here that force is equal to the Newton, R square is equal to meter square, m1 m2 means kg square. Okay, so the formula, or not formula, the unit of the gravitation constant is the Newton meter square upon kg square. So we are having a constant value of capital G, which is the gravitational constant. We are having 6.67 multiplied by 10 power 11. We can write this one as a Newton meter kg square. Newton meter square kg square. Okay, so this is a constant value of G we are having, that is. So this was about the Newton law of gravitation. Okay, there was a statement which was that the gravitational force is directly proportional to the masses, okay, and inversely proportional to the radius, to the masses, and inversely proportional to the radius. Okay, through this he calculated the gravitational force formula as well as the gravitation constant.